So, communication protocols. What do we mean by communication protocols and why is it so important? And as you saw in the list of contents, everything from now, from this topic to the end, is more or less talking about communication protocols. And so we need to understand why is it so important that almost like, let's say, around 80% of the module number 4 is just dedicated to communication protocols. So far we have seen what hardware and software does separately, right? But how does hardware understand whatever is coming to him? How does hardware know what it has to do, how it has to communicate with the sensors, how it has to communicate with others in order to carry out certain functions? As we mentioned in our discussions in when we were talking about basics of IoT, IoT calls for collection and sharing of data wirelessly, right? So we need to understand on how this data is being collected and how is this data being sent to the other devices and how is this sharing taking place. So this is where communication protocol comes in. Only once we understand how the data is traveling from one end to the other end, only then we'll be able to picturize the entire scenario of what is happening when you upload the code, on what is happening in the entire IoT network, how the different sensors are communicating with one another, how different modules are communicating with different sensors, and what all things are going on. So it is quite important to touch up on these communication protocols. So, first of all, the term protocol. What does it mean? In case you guys don't know, protocol means a set of rules, simple, and communication means communication. So, basically, communication protocols are a basic set of rules that have to be followed by the devices while exchanging data with one another. Communication between electronic devices is like communication between humans only. Both sides need to speak the same language. In electronics, these languages are known as communication protocols. So there are broadly the communication protocols which are in consideration in this particular module can be classified into three types. Number one, synchronous slash asynchronous. Number two, simplex, half duplex, full duplex. And number three, serial and parallel transmission. So let us touch upon these. Number one, synchronous and asynchronous communication. What happens in this? The term synchronous means there is a clock present in order to time the data that is being sent. What does it mean? It means that, well, now first to understand this, we'll first understand what a clock is. A clock is basically a signal. It's a series of continuous pulses of highs and lows which run at a particular frequency. So when we say we have a 6 megahertz clock, that means the frequency of the pulses, which are square wave, are at 6 megahertz. So why is clock so important? Clock is important because it helps us to synchronize. Why? Like, what do we mean by synchronize? That whatever data transmission is happening is in accordance to the transitions which are happening in the clock when it goes from a state of high voltage to a state of low voltage continuously. It helps us in synchronizing. So at the moment, all we need to understand is that in synchronous mode of communication, there is a presence of a clock, and in asynchronous mode of communication, there is absence of a clock. Okay, so we'll just look into the points differing between synchronous and asynchronous communication. Synchronous communication, there is a presence of a common clock signal, as I already mentioned. Asynchronous, absence of a common clock signal. Synchronous communication, there is faster data transmission. Asynchronous has relatively slower data transmission. Synchronous communication generally is used for parallel data transmission, and asynchronous is generally used for sporadic, means scattered data transmission. Synchronous communication, in synchronous communication, data is sent in the form of blocks or frames. In asynchronous communication, data is sent in the form of byte or a character. Synchronous communication is relatively costlier and asynchronous communication is relatively economical. Now, both of them have their own set of applications. There are a few applications which demand for synchronous communication. There are a few applications which demand for asynchronous mode of communication. So it depends on application to application. So the major differing point, I'll reiterate, is the presence of a clock. Now, in synchronous communication, When I say that there is a clock present, I also imply the fact that the clock should be same for both the transmitter and the receiver. Only then the data transmission and reception will be synchronized. Okay, and in asynchronous, as since there is no clock, therefore there's no such precondition required. Next, we'll look upon what is simplex, half duplex, and full duplex mode of communication. So, as the figure shown on the right hand side of the screen straight away gives you an idea what exactly do we mean over here. When we see simplex communication, there is only data transmitted from the client computer to the server in one direction. What does it mean? It means that the client computer can send data to the server, but it cannot receive any data from the server. It can just send data to the server. That's it, nothing else. In half duplex mode, what is happening? The client computer can send data to the server and it can also receive data from the server, but only one of these two processes can happen at a time. Either the client computer sends data to the server or it receives data from the server. But at one particular time instant, only one of these processes will take place. Simultaneous transmission and reception of data is not possible in half duplex communication. This brings us to the third category, full duplex communication. As you guys might have already guessed, in full duplex communication, the data transfer is both ways and simultaneously. So the client computer can be sending data to the server, and at the same time, it can be receiving data from the server as well. And both processes can occur simultaneously. So this is full duplex kind of communication. Let's just look into the differentiating factors between the three. Simplex mode of communication is unidirectional, half duplex is bidirectional but only one at a time, and full duplex is bidirectional but simultaneous. In simplex, sender can send data, but the sender can't receive the data. Half duplex, the sender can send the data and can receive the data, but only one at a time. And full duplex, sender can send the data and the receiver can receive the data simultaneously. The reason I'm reiterating this point is so that it's rock solid in your brains. Simplex has basically lesser performance than half duplex and full duplex. Half duplex has greater performance than simplex, but it has lower performance than full duplex. And of course, full duplex has the best performance of the three. Example of simplex mode are a keyboard and a monitor. Simple. When you are typing on the keyboard, you are not sending data back to the keyboard. You are just reading from it. So what is happening? Your keyboard is just one way communicating data to your computer. That's it. Same goes with the monitor. It is just receiving the data. It is just receiving the input that you give via the keyboard and via your mouse and via executing some program. It is not talking back to you. It is just receiving the data and it is just displaying it. It is not talking back to you. Important point. It is not talking back to you. Example of half duplex mode, walkie talkies. These are the best example for how to understand half duplex. As we said, both side communication, both side talking is possible, but only one person can talk at a time. What happens in walkie talkies? In walkie talkies, when a person is speaking, he or she delivers the message that he or she wants to deliver and then says over and out. Now, that is a symbol for the other person on the other end of the call in order to start his data transmission. Then he'll start saying whatever he or she has to say and then end his or her conversation part by saying over and out. Correct? So that is how half duplex happens. Both of them can't talk simultaneously to one another. And what full duplex? Of course, your telephones, smartphones, etc. When you call your friend, you can talk whatever you want. The other person can also talk whatever he or she wants simultaneously. There can be noise, there can be any kind of disturbance, and everything will be delivered to both sides. So it is like full duplex. Next up is serial and parallel data transmission. Now, what do we mean by serial and parallel data transmission? The figure on the right hand side of your screen gives us the perfect picture for it. Serial transmission is basically happening in series, that is, one after the other. One data packet is going, another data packet is following it, followed by the third one, fourth one, so on and so forth. But there's only one streamline of data packet transmission. Correct? It is going one after the other. What happens in parallel? As you can see in the figure, multiple streamlines of data packets are going simultaneously, parallelly, as we understand. Simple. So let's look into the differentiating points between serial transmission and parallel transmission. In serial transmission, the data bit flows in bidirection, as the arrows have shown. In parallel transmission, the data flows in bidirection but in multiple lines. In serial transmission, one bit transferred at one clock pulse. As I mentioned earlier, the in synchronous data transmission, what has happening is that the data transmission is done with respect to the transitions which are happening in the clock pulses. So over here, at one clock pulse transition, one bit is transferred. And what happens in parallel? 8 bits are transferred at one clock transmission. In case of synchronous parallel transmission, this happens. Okay, 8 bits basically means 1 byte. So in serial transmission, when only 1 bit is being transferred, at the same time in parallel transmission, 1 byte is being transferred. So that's like 8 times the data being transferred. But don't mistake it to be superior to the serial transmission. Both of them have their own importance and their own applications and their own essentiality in the communication domain. Now, serial transmission is cost efficient. Parallel transmission is not cost efficient because it is using more bandwidth. Serial is slow in comparison. Parallel is faster in comparison. Serial transmission is used for longer distances, and parallel transmission is used for shorter distances. Serial transmission, the circuit is relatively simple, and in parallel transmission, the circuit is relatively more complex. So we can make sense of all these differentiating points looking at the figure on the right hand side of your screen. So this is how serial and parallel transmission differ from one another.